Hello to everyone. Let's talk about the logistic regression. So, logistic regression is a model that is used for binary classification. Logistic regression is a combination of data of one or more independent variables to S-shaped logistic function. So we can see here where we have a event of success and the event of failure. So we here expect only a values between 0 to 1. So we can have 0 and 1. So that's why we have this option 0, 1, yes, no, true, false. We have here one example. A group of 18 students spent hours studying for an exam. The table below shows the numbers of hours spent and the test result for each student. So we have our spending and we have the result. Where is 0, it's failure, and where is 1, it's success. So the parameter used the parameters of a logistic regression are multiplied by maximum likelihood estimation. It's different from linear regression that we use R squared. So logged function follow Bernoulli distribution. As such, when the variable is exponent to Bernoulli distribution, it's called logged. To map the linear combination of variables, Bernoulli distribution probability, the following format is used, where we have natural log of hoods equal to natural log of p dividing 1 minus p. And here we have the function, but what we need is the inverse of this function. So to have inversion of this function, the following form it's applied, and now we can have the inverse of the function 0, 1, failure, success, false, true. And the logistic regression is an extension of linear regression, but most used for classification problems. So here we have the linear regression, and here we have the logistic regression. Here it's continuous variables, and here it's the outcome that we expect. It's a binary output. So to get to the binary logistic function, we call a natural log of p dividing 1 minus p to the linear regression. And what we need, the objective is to estimate p. So after this, we can have the estimate of p. Also, to adjust this model is necessary to estimate the b0 and b1 coefficients of the model. So to achieve this goal, we use a maximum likelihood estimation. So here we have the likelihood of observing data and the location that the maximized likelihood. So maximum likelihood finds the optimal way to fit the distribution to the data. So observation must be independent to each other. Dependent variable must be binary or dichotomous. When there are more than 2 categories of the max function, it's used. Linear relationship between dependent variables and log odds, no outliers, large sample size, little or no multicollinearity between the predicted variables. And thank you for watching. Please don't forget to subscribe and like.